Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good evening. So today for the subject EMM3218 heat transfer, we are from group 7. So we will present about one example of daily life heat transfer and one from the industry. So for the daily life, we have heat pad and exchanger in cryogenic industries. So the presenters will be me myself. I'm FITRI bin SHAHRUM 198590, and my friends Aleif, Hakimi bin ISMAIL 197551, together with NOORASHIKIN so BINTI ZULARIFFIN so 197659. Okay, so we will start about the daily life example of heat transfer. So for our group, we choose heat pad. Okay, next slide. So heat pad can be purchased in almost every shape, size and color. So in the heat pad itself, it contains a super cooled liquid that at the flex of a disc crystallize and it release heat. So once used, we can put the heat pad into the hot water until the crystal melt and then let it cool and it is ready to use again. So I think the heat pad is sold all around the world. Next slide. Okay, so what is heat pad for? So basically, this heat pad is used to the body part that pains. So how it works? First one, if we put the heat pad at the painful part of our body, it will dilating the blood vessel surrounding the painful area. Then it will increase the blood flow, provide additional oxygen and nutrient to help heal the damaged muscle tissues. The second one, it will stimulate sensation in the skin and therefore decreasing the pain signal being transmitted to the brain. And the last one, it increases the flexibility of the soft tissue surrounding the injured area, including the muscle and the connective tissue. Okay, so next slide. Okay, for the heat pad, the heat transfer concept that involved in this example are conduction. In this case, the heat is transferred from the skin by the conduction to the skin by the conduction process, where it direct contact occur between the heat pad and skin surface, which are solid to solid. So it will be the conduction process. Next slide. Okay, so how does this electrical heat pad work? So first we switch on the plug, then the supercooled liquid will become hot, and then we apply on the body part that pain, and then the heat will stimulate the part and the pain will be relieved. Okay, next slide. Okay, next we go to the sample question of the heat pad. So as we can see the question, an electric heating pad is applied to a patient's back to relieve muscle pain, assuming the surface area of contact is 100 cm squared. If the electric heating pad is kept at constant 50 degrees and the patient's skin temperature at the site of heating pad remain at constant 40 degrees, determine the rate of heat transfer. Okay, so for the solution, next slide. So we will use the formula Q equal to HA delta T. So the H is the heat transfer coefficient for the skin, A is the area, and delta T is the difference between in temperature. So we put the number H equal to 4.5, and then A area we calculate, and then we got the delta T, which is 50 minus 40 for the skin and the heating pad. So we get Q equal to 0.45 watt. So that's all from me. I will pass to the next presenter. Thank you.
Okay, thank you, IMM33. So for the industrial application, which is for my part and NOORASHIKIN, so we choose the heat exchanger in cryogenic industry, which is cryotherapy. Next. So for the introduction, cryotherapy means can be defined as the use of extreme cold in surgery or other medical treatment. As you can see from the right side of the picture, we can see that the chamber which is used as the medium for the cryotherapy. Basically, it is used to treat many skin conditions and some cancers such as prostate, cervical, and liver cancer. It also can remove damage or disease tissue that comes from a variety of medical conditions. So for the side effect is for the side effect of the cryotherapy is most people can recover quickly from the procedure and have some little pain. Next. So for the introduction, for the cryotherapy, it is used for first muscle recovery, pain management, precancerous cell, retinoblastoma, and skin conditions. Next. Okay, how does cryotherapy work? Okay, during cryotherapy work, the healthcare provider applies a stream cold to abnormal tissues. So as we all know that cell cannot manage to survive, and it makes the cell die after the treatment. The substance that used to create the intense cold for the cryotherapy is such as liquid nitrogen, liquid nitrous oxide, and argon gas. Next. Okay, as we all know that it use chamber, there are three components that involve for the heat transfer in the chamber, which is compressor, condenser, and also evaporator. So the compressor, it is a mechanical part that can increase the pressure of a gas and also for the pressure on a fluid. So for the condenser, it can condense a gaseous substance in a liquid state through cooling. How it works is it is when the latent heat is released by the substance and transferred to the surrounding environment. So for the evaporator, it can turn the liquid form into of a chemical substance into gaseous vapor or vapor. How it works is the liquid is evaporated into a gas of the targeted substance in that process. Next. Okay. For the heat transfer concept, there are two, which is the first one is it admissibility of a condensation on the surface of heat exchanger. As we all know that from what we learned, when the two part having like touch, it is the molecule, the heat flow from the higher temperature to the lower temperature. So the same concept was applied in this case, which is the temperature of the outer surface of heat exchanger must be higher than the condensation temperature. So the removal of heat from air to the surface of the heat exchanger was carried out by the natural convection. Next concept. Okay. The next concept is maintaining the inlet temperature. As we all know that in chamber, we need to maintain the inlet temperature by choosing the pressure of liquid nitrogen vapor in the heat exchanger tube. So the boiling point of liquid nitrogen depends on pressure. So to manage this case, we need to increase the vapor pressure to a level of increase more or equal than 0.2 megapascal. So it is possible to maintaining the inlet of temperature. The next is heat exchanger filled with liquid nitrogen successfully deal with an increase in heat load when patient enter, and the correct choice of operating pressure prevented air condensation. I think that's all from me.
Okay, so for the next part, I will explain the process of the cryotherapy. So in this process, cryochamber will be used in the cryotherapy, which it can reach a measly cold temperature as low as negative 110 degrees Celsius or equivalent to negative 166 degrees Fahrenheit. So for this whole process of the cryotherapy, it takes an individual up to 3 to 5 minutes for the whole process. So what is the process of the whole body cryotherapy? Before we go to the process of the whole body cryotherapy, it is necessary for an individual to use the correct clothing and also the gear protection, such as the cryo apron or the cryo glove. This is to protect ourselves from the very, very extreme cold temperature in the cryo chamber. So the next, after we ensure we are using the correct clothing, we first enter the first process of the whole body cryotherapy, which is the first cold chamber. So in this first cold chamber, we set the temperature of the cryo chamber into negative 10 degrees Celsius or equivalent to negative 14 degrees Fahrenheit. after our body are acclimate with this cold, we will enter the second process, which is called as second cold chamber, where we set the cryo chamber to negative 60 degrees Celsius or equivalent to negative 76 degrees Fahrenheit. Then, once acclimate, we will then enter the third process, which is known as the cryosauna. In this cryosauna, the cryo chamber will chill to the very, very lowest temperature that cryo chamber can reach, which is negative 110 degrees Celsius or equivalent to negative 166 degrees Fahrenheit. So for this cryosauna, we only spend 2 to maximum of the 3 minutes period, because if more, it will cause the frostbite. And then we will slowly reacclimate our body and the cryo chamber to room temperature. So how to do it? It is under the traversing the cold chamber in reverse. Okay, so what happened during this cryotherapy session? So under cryotherapy session, it happened the two type of heat transfer process, which is occur during the cryo chamber and also to our body. So first of all, the heat transfer process in the cryo chamber. So for this process, it almost same as the refrigerant process. So the first thing first, the liquid nitrogen, it will enter the compressor, and then the compressor, it will pump the liquid nitrogen into this system of the cryo chamber. So this will provide the cooling for the system. So the next part, so the liquid nitrogen, it will leave the compressor and then as a high pressure vapor, and then it will go to the condenser. So in the condenser, the liquid nitrogen, it will filter out the unwanted heat out of the liquid nitrogen into the ambient air. So right now the liquid nitrogen will become cool because the condenser already filtered out the unwanted heat. Okay, so then after cooling, the liquid nitrogen will go to the receiver, which is this receiver, it will act as the storage tank for any excess liquid nitrogen. So then the liquid nitrogen will travel into the expansion valve, and lastly, it will go to the evaporator, where this evaporator will pull the heat out of the chamber. So that is the process of the cryo chamber. So for the body, the heat transfer process for the body is where the cold induces the stimulation, which are transmitted by the nerve to the central nervous system. So first of all, once we enter the cryo chamber, our body will expose to the cold temperature of the cryo chamber earlier. So then the dry cold air will penetrate to our skin, and then it will narrow down the blood vessel. As you can see over here, it narrowed down the blood vessel, and thus it will reduce the blood flow to the painful area or the inflamed area. So because we reduce the blood flow to the inflamed area, it will then slow down the nerve transmission to our brain, and thus our brain will receive only fewer pain signal. So that is the heat transfer process in our body. Next will be explained by Aleif Hakimi.
Okay. For the case study, for the question is a cryogenic liquid. The fluid is stored in a 0.3 meter diameter spherical container in still air. If the convection heat transfer coefficient between the outer surface of the container and the air is 6.8, the temperature of the air is 27 degrees Celsius, and the temperature of the surface of the sphere is negative 1830 degrees Celsius. Determine the rate of heat transfer by convection. So for the question is, it is given D equal to 0.3 meter, HC, which is convection heat transfer coefficient, equal to 6.8. Temperature of the air is 27 degrees Celsius, and temperature of the surface is negative 183 degrees Celsius.
Okay, for the solution, we will calculate the rate of heat transfer by using the equations of the rate of heat transfer equal to the average heat transfer coefficient times by the cross-section area of the sphere, in bracket ambient temperature minus by the sphere surface temperature. So from this equation, we already get all of the value, only that we didn't know the area for this part. So we are using the 4 pi r square, which from the question, we know that diameter is equal to 0.3. So we substitute the equation, the value into this equation, and thus we can get the area is equal to 0.2827 meters square. Then we substitute all of the value into the equation earlier, so we can get that the rate of heat transfer between the surface and the container and the air is 403.7 watt. I think that's all from us. Thank you.